issue towards the pulley is upwards siya and perpendicular to the surface of contact, no? Ang atong surface of contact ani is horizontal man. So perpendicular gina always ang normal force. And since wala may gihatag nga weight ang atong pulley, so wala po nato siya gi-indicate. And then kani pud nga pulley is securely attached at its center. So na po na siya mga reactions dira no? Eight man sa figure nga pinned connection ni siya. So we have two reactions, no? We have the R sub V for the vertical reaction and then we have the R sub H for the horizontal reaction. It's obvious nga ang direction sa horizontal reaction kay towards the left since iya i-counteract ang ato ang frictional force nga towards the right. And additionally, kana pod atong vertical reaction is upward siya due to the fact nga iya pod i-resist ang ato ang downward force due to the 400 pounds nga applied force. Okay. So, nakompleto na ang mga external forces nga ni-act sa ato ang pulley. So, the next step is to solve for the unknown forces, no, for this FBD. So, narantay duha ay tulo ka mga equilibrium uh, equations diri Now, since we are after with the value of our force P, in order to optimize our solution, we will focus on finding the value of the frictional force and the normal force respectively, no? Arid ta malangay kay og ato magod kumpletohon ang tulo, no? Well, madugay ta and then ang gamit sa remaining ng mga equilibrium equations are used to solve for the reactions. Kunya kay wa man gi kuano wa man gi pangita ang reactions diri So pwede rag summation of moment dayon ta no. Kaya if we take summation of moment at the center of this pulley that is equal to 0 no to attain equilibrium positive siya kung counterclockwise. Now ang mahitabo ani is that the forces RH, RV, and the normal force has no moment, no? They don't have any moment at all. It's because ang ilahang point of application is towards the center of our pulley. So, ma-zero ilang moment yani. What's left are these two forces, the frictional force F and the 400-pound force. So, for the frictional force F, ang iyang ma-produce nga moment is counterclockwise. So, positive siya. Whereas, ang ihapod, kuan, ang ihapong moment arm, its distance from the center is the radius of this larger circle or the outer circle. That's 20 inches. So, butang ta diri at 20 times the frictional force minus the 400 pounds. So, the reason why minus here is because it it has a tendency to rotate this pulley in a clockwise direction. So minus ang iyang moment arm is the inner radius, no? Or the radius of the inner circle. That's 10 times 400. That is equal to 0. So F therefore is equal to 10 times 400 over 20. So that will give us half of 400. That's 200 pounds. Okay, so this is the value of our frictional force. Now we are going to use this on our second FBD, no? FBD at the brake lever so that we can solve for the unknown force P. And aside from the frictional force, we need to find also the value of our normal force. Kay kanisang normal force, it will also reflect, ma-reflect po ni siya sa FBD sa ato ang brake lever. So solving for the normal force N, use the concept no that the frictional force is equal to the product of the coefficient of friction times the normal force. So therefore, the normal force is equal to F over mu. Now, the frictional force is 200 pounds divided by the coefficient of friction mu. So, ito na indicate dito, ano? uh, mu is equal to 0.2 as stated in the problem. So 0.2. Now ato na siya i-plug in sa tong cycle. 200 over 0.2. We have a normal force equal to 1,000 pounds. Okay, 1,000 pounds. Muna siya atong normal force N. Okay. So nakuha na nato ang frictional force F and normal force using this FBD no of the pulley. Now, if you or if gi-required gali diri a class ang kanang kuan ang kanang value sa ato ang reactions no at the center of the pulley. If gi-required this as a problem, then perform summation of forces along the horizontal and along the vertical to solve for the reactions. Pero wala gay gi-require, just like sa kaning nga problem no o man gi pangita, then we can proceed directly to the FBD of the second rigid body, which is our brake lever. Okay. So, diri ata, no? This is the FBD of our brake lever. Ang atong brake lever consists of our kaning brake arm and our brake shoe. Then kaning brake arm is kano siya, mo rotate ni siya about this hinge or kaning pin connection. Okay, so ato i-indicate ang mga external forces. The first one is our force P, no? Mo ni siya ang mag activate sa ato ang braking action towards our pulley. Then at the brake shoe, applying Newton's third law, kaganiha sa FBD sa ato ang pulley, ang normal force is pa-upward. So by Newton's third law nga uh, for every action there is an equal and opposite reaction. So ang force pod ni pulley towards the brake lever is downward. So downward na diri ang normal force but the same gyapon siya in magnitude. And then same goes with the frictional force. So kang pulley pagtuyok niya ang force nga gi-act ni brake shoe towards the pulley is to the right. So in return, by Newton's third law, si pulley pod mo act pod siya og corresponding frictional force to the left. So man siya diri no, ang F diri is to the left kay ang resistance to the left man due to this pulley. And then ang normal force is paubos. Now, ako pod gi-indicate diri ang mga reactions that exist at this pin. So ako lang gi-denote by M, no? M sub H and M sub V. So that corresponds the vertical and horizontal components of our reaction force on this pin. Okay, so wala na may lain nga mga external forces, wala may gi-indicate pod nga weight aning brake arm. So we're good to go. Now, to solve for P right here, the best way since gihatagan naman tag values sa ato ang normal force no, N is 1,000 pounds. Then our frictional force F is equal to 200 pounds. Now, to solve P directly, uh, proceed dayon sa paggamit og summation of moment no for this one. Kaya ang summation of moment mao ay pinaka the best to determine directly the value of force P. Kay og mag summation of forces vertical ta, natay duha ka announce no, the vertical reaction at this pin as well as P. Kung mag horizontal pud da, well ang atong makuha is the horizontal reaction and not the force P. So to optimize our solution process, we will use directly or we will proceed directly to summation of moment at the pin. And that is equal to 0, positive kung counterclockwise. So, unsa may mga forces nga maka-cause og moment at the pin. So, naatay force P. So, ang distance ni P from the pin is the sum of 16 and 32, no? P. Then makaproduce siya og kanang counterclockwise, no? So positive na siya. Then ang normal force makaproduce siya og clockwise. So minus ang distance in normal force is 16 times n. Then si frictional force F makaproduce pud siya og gamay nga moment, no? Kaya naman siya perpendicular distance from the pin which is equal to the thickness of the brake shoe. That's 8 inches. So plus 8 times the frictional force F is equal to 0. Solving for P, so ato siya i-transpose ang normal force and the frictional force. We have 16n minus 8f all over 16 plus 32. I-substitute ang mga values. So 16 times 1,000. Then ato po i-substitute ang value sa atong frictional force. So minus 8 times 200 all over 16 plus 32. So pila man ang ato ang needed nga force P. Okay, so ato i-substitute. We have 16 times 1,000 and minus 8 times 200 divided by 16 plus 32. Okay, so the answer is 300. Exactly 300 pounds. So, maone siya value sa ato ang force P required to prevent the pulley from rotating. Okay. So, naay ko na ni pangutana before ta mo proceed sa next nga sample problem. Class, naay pangutana ni? Okay, wala ra. So, let's proceed to the next problem, no? So, naata diri ay another rigid body gihapon kay naman siya dimension. So, as shown in the figure, a homogeneous cylinder 2 feet in diameter, so as shown, and weighing 120 pounds is acted upon by a vertical force P. So, kaning gi-indicate sa ato ang blue nga arrow. Now, determine the magnitude of P necessary to start the cylinder in turning. Assume that the frictional force F, or commonly atong gigamit ani kay mu man, is equal to 0.30. Okay. So, pila daw ang required nga force P para mo tuyok ni siya, no? So, natay gitawag nga direction of impending motion, no? So, na siya tendency kung applyan gid nato ni og enough nga force P, it will tend to rotate in a clockwise direction. So we have direction of impending motion. Okay? So, ana na siya. Now, kung ato i-analyze ang system, no? Natay duha ka contact points, no? Na diri as sa horizontal o nasa incline. So, in these 2 points, natay friction nga nag-exist. Okay? So, ato na siya indicate sa ato ang FBD later. Now, mo ni siya ang corresponding FBD, no? FBD of the cylinder. Now, kung ato kita ng system, we only have one rigid body, no? And that is a cylinder nga ni rest siya on this horizontal surface and the inclined surface. So, ato i-indicate ang mga external forces. We have the force P, this one. We have the weight of this homogeneous cylinder. So, since homogeneous siya, so concentrated ang iyang weight at the center, as shown. Then, this cylinder has a radius of 1 foot, kaya ang given kay diameter 2 feet. So, divide by 2 na siya. Then, as what I have told you, we have 2 contact points, no? This is our first contact point and this is our second contact point. Now, sa first contact point nato, no, natay duha ka forces nga ni-act diri And before that day, ato indicate ang iyahang kanang kuano, ang iyahang impending motion. So, umano siya tong direction of impending motion, which is kuan siya pa clockwise due to the pulling action of our force P. Okay. Sa first contact point, ang normal force always act gid na siya towards the object, no? Towards our rigid body. So N1 pa upward, then towards the center gid na siya sa ato ang kanang kuan, ato ang homogeneous cylinder. Then since ang kani siya nga cylinder is mo naman siya tendency nga mo rotate pa clockwise, so therefore ang resistance ani due to the horizontal surface is pa rightward as shown by this F1. So man iyang frictional force pa rightward. And on the other hand, at the second contact point, no, always ang normal force acts towards the center of our object or our rigid body, the homogeneous cylinder. And then ang iyang force, I mean, iya frictional force, no, due to this inclined plane is pa kuan siya, pa upward, no, due to the fact nga ang kaning cylinder na tendency nga mo rotate pa clockwise. So iyan is siyang pugna, no, ang resistance is pa upward. So na indicate naman ang mga frictional forces as well as the normal forces and other external forces. So we're now good to go, no, proceed ta sa paggamit sa mga equilibrium equations, no, the three equilibrium equations: summation of forces along the vertical, horizontal, and summation of moment. So ato indicate diri the requirement for this problem is to solve for P. Okay, solving for P. So natay FBD sa ato ang kanang cylinder. Now, if we take the summation, no? Kay kung mo take tag summation of moment at the center, what will happen? May tabo, mga wagtang ang mga normal forces, di ba? Ang kaning N1 and N2. Okay? Mawala sila. Leaving only the kuan, the frictional force F1 and the frictional force F2. But there's another way of um, getting the values of this forces, no, kaning F1, F2, and N2. And then since naman tayo relation, no, sa kaning F1 and N1 as well as F2 and N2 nga ilahang frictional force kay ay ilahang coefficient of friction kay 0.3. So pwede na po ka og mag-take og summation moments ani anywhere sa ato ang given nga kanang figure. Pwede ka mag-take og summation of moment at point 1, no, kaning point 1, so that you can solve directly the forces F2 and N2. Pwede pa na siya. Then pwede po ka mag-take og summation moment at point 2 para ma-solve dayon nimo ang imuhang duha ka forces F1, N1, and alright, ang P, no? So P po di ay, no, napaday P. So tulo ni ka mga anons daw, pero og ato ihapon, no, ihapon natay usa, duha, tulo, upat, lima ka mga unknown forces, pero ma-reduce ni siya into 3 unknown forces due to the fact nga kaning ato ang F1 and N1 can be combined, no, using the relation of the general formula sa ato ang friction nga F1, no, namtay relation F1 is equal to mu N1, and the other one, F2, is equal to mu N2. So, pwede na to makombining duha ka mga unknowns, F1, N1, and F2, N2. So, mahimo lang tulo ka unknowns. So, with 3 unknowns, no? So, pwede na to ma-solve using the 3 available equilibrium equations. So, mato siya. Sa moment, daghantaan ni. Now, pwede ta mag-start sa katong summation of forces, no? So number 1, take summation of forces along vertical that is equal to 0. So positive kung upward. So unsa may mga upward forces? we have the force P, then we have the normal force N1, and then kaning F2 ug N2, no? Naka-incline man sila. So naa ni sila corresponding mga vertical components. So ato na sila i-resolve, no? So ito i-drawing diri Okay, mo na siya to F2, no? Mo na to F2.
Ay, kapoy talaga, pero malag. Wala, nawa internet. Shit. Nasa baba. Ano? Sige lang. Kaya lang gapon pag na.
To their components along horizontal and along vertical. So sa N2, mo ni ang iyahang N2 horizontal, then kani diri ang apart mo na iyahang N2 vertical. On the other hand, for F2, mo ni ang iyahang vertical, F2 vertical, then kani siyang sa ubos, mo ni ang F2 horizontal.
Ano sa una de, si Princess
Okay.
de Avatar.
So vertical forces man itong i-consider. So for F2, we have um, plus
Kaya ang balik sa
siya
wifi.
pangitaw niya yung value. So, kuhan siya. Wait na ha. Ang F2 vertical is equal to F2. Ang atong gamiton is sine 60 degrees. Then for N2, that is
Sa tayo pangan tayo wifi. Wifi
plus
speed.
N2. Pa-upward man siya. Then sine 30 degrees.
Ang problema sa natin ito pa.
N2. So, ang equation above will become P plus N1, then plus mu N2 sine 60,
Okay, pag nga na,
then
kuhan ka.
plus
Pag nga na hotspot.
N2 sine 30,
Ito, nawa na sa wifi.
60 plus sine 30 is equal to 120. Then, ato i-simplify na nga portion ang coefficient sa N2. So, this is plus
Kasan charger ko?
N2 times uh, 0.3 sine 60 plus sine 30 is equal to 120.
Kabantay ko sa battery.
Now, atong i-simplify ang coefficient sa N2, we have 0.3 sine 60, then plus
Pero ang record,
sine 30.
pero wala ko siya. Gusto
We
ko
have
laptop na mo control na
this
wifi.
one, kaya lang,
Mo black screen
or
na siya.
pwede po na, kaya lang. So, we
Black.
have, pwede po ni, kaya lang, 10 plus 3 square root of 3 over 20. So, P plus N1 plus 10 plus 3 square root of 3 over 20 N2 is equal to 120. So this is our equation 1. Ato na i-reviewhan be. Okay, so sakto man. So nanatay equation 1. Next is perform na punta og summation of forces at the horizontal. No? So diri ata number 2, summation of forces horizontal that is equal to 0 So positive kung to the right siya. So ang mga forces to the right, we have uh, F1, then ang atong F2, balik ta sa previous nga slide, ang F2 na to, positive ang iyahang horizontal component and that's cosine 60, no? So plus F2 cosine 60, whereas si F1, no, si F1 na, si N2 na to, wala siya, no? Si N2, wala ni. Ay, I mean, wala ka ng negative, sorry. Negative ang iyahang horizontal component. That's cosine 30. So indicate minus N2 cosine 30 degrees, that is equal to 0. So, ano may laing mga horizontal forces. Now, naman tayo relation, no? But F2 is equal to mu N2. And F1 is also equal to mu N1. So, therefore, mahimo na siya mu N1 plus mu N2 cosine 60 minus N2 cosine 30 is equal to 0. So, i-substitute ang values, we have 0.3 N1 plus 0.3 cosine 60, then minus cosine 30, N2 is equal to 0. So, this will be our second equation. Pero ato na siya i-simplify ang iyang coefficient for N2. So, 0.3 cosine 60 minus cosine 30. That is equal to 3 minus 10 squared root of 3 over 20. So, kani, ato pod ko pitoon siya nung na siya P. Para same na siya og arrangement sa equation 1. So, 0 iha P diri, kaya mo siya P. Then, plus 0.3 N1. Then, plus, ito tayo naka-indicate sa calcu, 3 minus squared, minus 10 squared root of 3 over 2. So, 3 minus 10 square root of 3 over 20. This is N2 is equal to 0. So, this is our equation 2. Now, for the last equation, we will perform summation of moment at the center of the cylinder that is equal to 0. So, positive kung uh, counterclockwise ang iya ma-produce nga rotation. So, si P, makaproduce siya og kanang clockwise. So, therefore, negative iya ha, no? Clockwise man iya ma-produce with respect to the center. So, we have negative P. Then, ang iyahang moment arm is equal to the radius. That's 1 foot. Then, ang kaning N1 and N2, wala na sila'y moment nga ma-produce since direct comes they act directly at the center. So, we only have the frictional forces F1 and F2. So, for F1, makaproduce siya counterclockwise. So, plus F1 multiplied by its arm, that's 1. And then, plus F2 multiplied by its arm, still 1 foot. That is equal to 0. Then, gamit na punta sa relation, no, nga F1 equals mu N1 and F2 is equals to mu N2. So, ito na i-substitute. We have negative P plus mu N1 plus mu N2 is equals to 0. So, we have negative P plus 0.3 N1 plus 0.3 N2 is equals to 0. So, this is our equation 3. Now, na-complete na nato ang 3 equations. Ato siya i-combine. So, step number 4, combine equations 1, 2, and 3. No? Ato to i-combine. Ang first equation, we have P plus N1 plus 10 plus 3 squared of 3 over 20 N2 is equals to 0. The second equation, 0P plus 0.3 N1 plus 3 minus 10 squared of 3 over 20 N2 is equals to 0. Then the third equation, negative p plus 0.3 n1 plus 0.3 n2 is equals to 0. So, pila man ang value sa ato ang p, n1 and n2. So, namatay tulo ka equations with three unknowns. So, kaya ni sa atong cycle, no? Go to mode, select 5 for equation, then select 2 for 3 equations, 3 unknowns. So, ang atong A ani is the coefficient of P. So, sa first equation, that is 1. Ang B kay coefficient sa N1. So, sa first equation, 1 gihapon. Then, sa C, mo na siyang coefficient ni N2. So, diri na atay 10 plus 3 square root of 3, then divided by 20. Okay. Then, for D, mauna siya to ang kuan constant. Dapat naa siya nabutang sa right side sa itong equation, so 0. Then the next um atong next aning equation, so kani siya we have 0 for p, then 0.3 for n1, and then wait, ang atong equation 1 I think murag dili siya 0, no, 120 ay sorry. Okay, og mag 0 ni tanan mura og ma 0 pud niya itong mga values kani siya nada ni siya 120, sorry, kalimtan ako. This is 120. Okay, balik ta sa to ang cycle ato sa kuan sa babaw. Okay, this must be 120. Okay, so 0.3, then sa ikatulo this is 3 minus 10 square root of 3 divided by 20. Okay, then ang iyang constant wala, 0. Then the last one we have negative coefficient sa p, negative 1, then 0.3 sa n1, and then 0.3 sa n2, and then 0 gihapon na iha constant. Press equal, man siya ang value sa to ang force p, that's 29.29. 29.29 pounds. Then ang n1 nato, ato lang po isuwat o gapil, n1 is 68.81. 68.81 pounds. Then ang atong N2, the Z, 28.83. So N2 is equals to 28.83 pounds. So our answer here is the approximate value of our force P, which is almost almost 29.3, na 29.3 pounds. Okay. So naay pangutana ani sa ato ang second nga problem.
Wala, sir.
How about the others? Nasunod ani? Ang kaning sa summation of moment ha, you can select any point on our rigid body. Pwede sa center, pwede sa kaning first contact point or the second contact point. Still the same ra gyapon imong ma-arrive nga answer ana. Okay, wala na gyud. So that's it for our first lesson. Now let's proceed to the second nga lesson. Ang atong second nga lesson, by the way, are the applications of friction. So what I have told you sa last nga meeting, no? After sa theory, discuss sa sayang applications. Okay, na kita na ninyo ang kuan? PowerPoint?
Yes, sir.
Okay, tara sir.
Okay, nakita ra. So, proceed ta ani. the different applications of friction. So, as shown in the figure, natay tulo diri the first figure shows the nomenclature of our wedge, no? So, wedge is a type of simple machine. Then the second one, this is our power screw, natay threads ani no? So kani uh, one of our simple machine pod nga ni-utilize siya sa friction so that it can perform its task. Then the third one is we have the belt and pulley, no? Belt and pulley kay duham na ni kabuok. So ni-utilize gyapon siya sa friction in order to perform its task. Pero uban pod nga mga applications wherein we don't need the friction, no? Kung let's say for example, if we allow one object to flow smoothly with respect to the other object, so we need to remove or minimize kaya di man gyud na lisod man kay i-remove ang friction, so we have to minimize the friction. Pero sa kaning nga mga simple machines, in order to have a huge mechanical advantage, no? Ni-utilize siya sa friction to perform its task. Now, for our second lesson, no, sa kaninga module, we only have one learning outcome. That is, you will be able to apply the concept of friction in analyzing the forces that interact on wedges, power screws, belt and pulleys, and lastly, we also have the rolling element. No? Diri bisag nata siya mga applications, still gamiton gihapon nato ang kadtong concepts from equilibrium of force systems, no, tanan-tanan na, plus the concept of friction to analyze these different applications of friction. Now, for this meeting, we will start with the wedges, no, kanisa siya. Then, marag sa kaninga meeting, no, kanira pod ang ato ang ma-tackle. So, tomorrow na lang tong power screws, belts, and rolling friction. So, for wedges, before ta mag-analyze sa mga forces nga nag-interact niya, let's talk about the uh, the theory behind this simple machine, the wedge. Unsa man siya? So, a wedge is simply a triangular tool often made of metal, wood, stone, or plastic. So it is thick on one end and tapered to a thin or sharp edge on the other end. Na kung natay normal nga block, sorry, murag nakuan siya, wala tarong kan siya. Normal block, well, wala tayong mabuhat na yana. But if we taper one of its side, no, naka-taper siya, okay, naka-angle na siya. So we can create this triangular shape and this is our wedge, no? So ang atong common nga makita sa atong surroundings, we have this one kaning nail sa ihat tip, no, kaning magpa-drive uh, through our wood, no, para makapilit ni siya, maka securely fasten ni siya og two objects. So nigamit siya sa wedging action, no, para mo cut through siya sa wood, mo penetrate siya. We also have the zipper, no, atong zipper. So wedge shape po ni ang iyahang mechanism sa sulod para ma-close niya ang kaning duha ka side sa ato ang uh, cloth. Then we have the knife, very obvious. Kung imo kita na ihatom mo ay wedge shape na siya, no, pa-triangular shape, as well as our screwdriver. So the reason why makatuyok ta, no, or I think mag chisel siguro ni, no, chisel makakat ta og wood, it's because of the wedging action, no? Triangular ay hatip, as well as the axe and our shovel, no? Naka kanang triangular ang ilahang edge. So maka-cut through siya, maka-split siya og material into two parts, no? So wedges work by changing direction and force applied to it. Just like our axe, no, nga ato ang gi-strike sa ato ang wood. So our object here is the wood, our wedge is our axe. Then if we apply a vertical force, no, sa atong axe towards the wood, what happens is iyan ning na-cut through ang wood and at the same time iya pon siya na-split. So from vertical force na transfer siya into this inclined forces, no, ngani na mo ni siya kaning inclined forces mo siya nagpa-split sa wood into two parts. So diri na harness nato ang kaning uh, triangular shape sa to ang axe to cut this wood into two equal parts. And asa man ang friction ani sir? So if we have enough friction, no, between the surface of our axe and the surface of our wood, we can create a bigger force that will split the object into two equal parts. But if slide siya, what will happen? So kung slide sila, slide po ni, it cannot perform its task. No? Di siya maka-split. So later, when we analyze wedges, ato makitaan nga, it's very important to maintain, a desired frictional force between two surfaces in contact sa ato ang wedge. Okay, so this is how the wedging action works. Then, ang mechanical advantage or for every simple machine, lagi na siya gitawag na mechanical advantage, no? So, for the wedge, its mechanical advantage is higher daw when the wedge is longer with a thinner tip. So, natay duha ka klase di ay sa tong wedge. We have the double wedge and the single wedge. So, kung taas niya tong wedge, no? So, magtika taas kay siya. Then, magtika nipis. So, kani siya, tako ni siyang mechanical advantage, meaning it has the tendency to transfer a huge amount of force towards our object, no? Grabe yang amount of force nga iyang ma-transfer, no? From this wedge to the object nga iyang i-split or iyang i-cut. And with this, in analyzing a system of bodies na naa siya wedge or other blocks, yung buhaton is you have to analyze these important parameters. So the ability of the wedge to cut or split an object depends on its wedge angle, no, kaning the angle between these two inclined surfaces sa atong wedge, the coefficient of friction, no, that exists between the contact surfaces, and lastly the applied force, no, that's your input force. So kung gamay ra pud ang input force o gamay ra pud kag ma-generate ana nga kanang kuan nga kanang wedging action. Pero dako kay mo amount of force, so mo nang kung ganahan juga nga ma-cut gyud mo ang wood, so di ba grabe mo i-exert nga force niya na. And then that's the reason pod kung habulan nimo ang axe niya na, no, dili siya sharp ang tumoy, so most likely mag-slide na dira, no, less ang friction niya na. So make sure to sharpen your wedge para maka perform siya sa iyang task efficiently. Okay, so proceed ta sa procedure in performing the force analysis on wedges. So this is how you solve problems nga nag-involve siya og mga wedges and blocks. So the first step is to construct, di gini mawa ni bisag asa tang application. Construct an FBD for each wedge or block na na-involve sa ato ang system. So just like this one, we have two wedges here. So kung nakay duha ka wedges, make sure to construct two FBDs pod. So diri let's focus on this wedge highlighted in light brown, kaning light brown. Then kaning gray mo na siya ang wedge nga ni interact sa ato ang light brown nga wedge. So ang mga forces na nag-interact sa ato ang light brown nga wedge, ato na siya i-indicate ang mga external forces. Now we have the applied force P, we have its weight, no, kung mention, so you have to indicate that one. Always gina siya na sa iyahang center of gravity, no, or sa iyang centroid. Then kaning nga wedge, kaning gray nga wedge, no, due to the application of force P, so kaning nga wedge mo resist ni siya in the opposite direction sa ato ang light brown nga wedge. So manang naka-indicate ang yang frictional force F towards the left. And then di gyud malikayan no nga sa contact surface na gid tay normal force niya na. And the normal force is always perpendicular to our surface, contact surface. Now the second one, in order to simplify the external forces sa ato ang mga wedges and blocks, what you need to do is try to combine or sum up these two forces no nga related sila to each other. These are the normal force and the frictional force. So diri combine the frictional and the normal forces into a single reaction force and imo na siya i-denote by R. Now, ako na siya gi-explain ngadto sa kanang kuan theory behind friction. And then once imo na siya i-combine, you have to indicate its direction angle, no? Kadtong angle phi, which is our angle of friction. The angle between the uh, frictional force, I mean the normal force and the reaction, no? Mao na siya. The normal force and the reaction as shown right here. So instead nga natay F sa ubos no diri instead of F and the normal right here no and imubuhaton di ba mag-create ka ni og kuan parallel nga force vector sa F. So ang angle between the normal force and your reaction mo na siya imong indicate og appeal, that is our angle of friction phi. So from 4 external forces down to 3 na lang. So you have to simplify that one. Gamit kina siya para dili ka daghan og mga unknowns. Okay? Mo na yung buhaton. Then og i-record di class nga solbon ang normal force and the frictional force. Well, na naman kay reaction, use the the right triangle no nga model wherein you use the tangent no tangent phi is equal to the ratio of F over N. Then you can also use the sine of phi, which is equal to the ratio of the frictional force and the reaction force. No? Malang na siya. Okay, ikatulo. Now, once na kompleto ng FBD, imo na na-combine ang mga normal and frictional forces, the next step is, if there are three forces acting on the wedge or the block, you are going to use the force triangle method, no, to solve for the unknown forces. Di ba kung naay three forces on a single particle, di ba, force triangle, triangular shape man ang ma-generate nato sa ato ang mga force vectors. So kung force triangle, dali ra kay no need na the summation of forces along x and along y, no need na for resolving the force into its equivalent components. What you need to do kung naay tulo ka forces, just like this one, you can use sine law or cosine law to solve for the unknown forces and unknown interior angles, no? More na siya. Now, kung ang Osaka wedge or block kay more than three forces, like up to four forces, so you're going to use the component method to solve for the unknown forces. No, yan na lang. Component method katong uh, i-resolve i-resolve sa ang mga forces labi nag mga inclined forces into its equivalent components no along vertical and along horizontal. Then i-add up nimo ang mga vertical components as well as the horizontal components, then use the Pythagorean no the Pythagorean theorem equation to solve for the magnitude, and use the arctangent to solve for the direction of the resultant. So nga na lang. Next, number 4 no, the last step, once na solve na nimo ang mga unknown forces, you have to repeat the steps. The first step, second, and the third for the other wedges or blocks. Balik ko nimo hantod nga mahuman ka sa tanang mga wedges and blocks. So this is how you perform the force analysis on wedges. Okay, so naatay one problem for the wedge. No? So we have here, determine the force P required to start the wedge shown in the figure. So natay duha ka wedges diri actually usara ka buok no kanirang trapezoidal o forma kay kani usa block man ni siya no kay rectangular. So we have a wedge and a block as shown in the figure. Now ato pangitaon ang force P required to start this wedge. So naate applied force P, and this will cause the wedge to move downward, no? Then indicate po diri nga the angle of friction for all surfaces in contact is 15 degrees. Now 15 degrees right here, this is our angle phi, no? Phi 15 degrees. So asa man siya mo exist sa point of contact. So ang atong wedge is naka-contact man siya sa ato ang inclined wall. So naa na diri ay friction. And then si wedge pod ni contact mo siya sa to ang rectangular block at this surface. So napunta diri ay friction. And then lastly, our rectangular block is ni contact pod siya sa to ang horizontal surface, no? Napunta diri ay friction nga ni exist. So we have three contact surfaces. So therefore natay tulo ka mga reactions, no? R1, R2 and R3. Contact 1, contact 2 and contact 3. Okay. Ang requirement ani is to solve for P, no? Solve for P. Now diri ato indicate pod ang impending motion. So since this is our applied force, this is used to start the wedge from moving. So ang iyang direction of impending motion ani is paubos, no? Direction of impending motion. You have to indicate this one class kay it's very useful, no? Labi na pag-assign sa direction sa ato ang mga frictional forces. And on the other hand, kung mo exert og downward force atong wedge, ang effect ani sa rectangular block mo move ni siya pa rightward, no? Ana. Kaya man ni siya pa split. Okay? So mao po ni ang direction of impending motion sa ato ang rectangular block. So once na-indicate na nimo, you're now ready to construct the FBD for this wedge. Okay. So this is now the corresponding FBD of the wedge. Okay, so ato ni tagsa-tagsaon. Sa kani ato ang dito siya sa wedge, sorry. The reason why I I started with the construction of the rectangular block, it's because kung sa wedge ta class, daghay mga unknowns, no? Ang given na nato kay naa sa rectangular block. So ang ato mag FBD ta sa rectangular block, then once ma-solve na to ang mga unknowns from the rectangular block, mo proceed ta sa ato ang wedge, no? So again, diri ta mag-start sa rectangular block kay namang mga almost given diri. Then once ma-solve na to ang mga reactions at these two contact surfaces, no? The contact number 2 and contact number 3. Now, ang gate pass nato para ma-solve si P is the value of our contact surface 2, no? Ang reaction diri. So mag-una ta sa rectangular block before ang wedge. Mo na tong atake for this problem. Okay, so FBD of the rectangular block, mo ni siya. So naa siya external force nga 200 pounds pa downward given na. Then pa leftward nga force 500 pounds. And then wala may gi-indicate nga weight aning rectangular block, so wala lang. And then kani siya nga portion mo na siya ato ang contact surface number 2. Then kani siya nga portion is our contact surface number 3. No? So the reason why ang R2 kay paubos siya, it's because ang direction of impending motion sa atong wedge is pa downward. So DOIM. So si wedge mo kuan siya, no? Kanang mo apply siya og kanang pressure pa downward ni block 2. Then mo move man ni ato ang block 2 towards the right side, no? DOIM, the direction of its impending motion, pa right man siya. So therefore, ang kuan pod, ang resistance due to the horizontal surface is pa kuan pod, pa top left, no? Mo ni siya as shown by this R3. Pa top left pod siya. Then kaning R2 again mo ni siya ang friction. So it's a combination of the frictional force nga paubos due to the wedging action of our wedge, and then napon siya yung normal force nga paana. So again, step number 2 sa atong force analysis sa wedge, ato na i-combining F ug ang N, mo ning natay R2 ani. Then ato indicate ang iyahang angle of friction phi. So i-indicate na. Then same goes with R3. So si R3 na siya frictional force F3, then napod siya normal force nga pasaka, this is N3. Di-combine na siya, so we have here R3. Then mo ni ato ang angle of friction phi. That is the angle between the reaction and the normal force. Okay, so ato iphon pila ka buok mga external forces sa ato ang rectangular block, upat. So dito maka-create ani og force triangle. So we use component method, no? So use component method to solve for R2. Okay? Ang R2 ra may solve na to ani so that we can bridge our solution from rectangular block to the wedge. So ato ni siya plot sa atong Cartesian plane or pwede pog magbase na ta diri pwede ra siya. Pero basi maglibon ang uban, ato lang ibalik diri plot. So we have the 200 pounds paubos. Okay, kani mo na siya to ang 200 pounds. Then natay R2 na paubos ato idikit diri This is our R2. So if this is phi, this is also phi. Then our R3 pataas no paana siya. This is our R3. If phi ni siya, this one is also phi. Then ang atong 500 pounds leftward siya. So this is our 500 pounds. Okay. So dito ayos na ipangutan na. Pakomyos
Dili
na ipangutan na.
2,200 pounds, sir. Ang iya weight. Ay, boss ko, sir.
Yes. Ay, oh, sorry. So, kana. Thank you. So, 2,000 day. Sakto. Now, gihataga matag value no sa to ang angle of friction, that's 15 degrees. So, ato lang ibutang dira. Okay. So, mag-perform ta summation forces vertical that is equal to 0, positive kung pasaka. So, we have R3 cosine niya no? R3 cosine phi. Then ang R2 na to ka negative minus R2 sine na iya. Sine phi. No? Kani man nga part sine. Then minus 2,000 is equal to 0. So ato lang i-arrange no nga mag-una si R2 followed by R3. So we have negative sine ato dayon i-substitute ang angle of friction, that's sine 15 R2, then plus cosine 15 R3 is equal to 2,000. This is our first equation. So we need one more equation to solve for R2 and R3. So proceed the summation of forces horizontal is equal to 0, positive kung towards the right. Okay, so natay R2 cosine phi, then minus R3 sine phi, then minus 500 is equal to 0. So ato i-substitute ang values, ato i-transpose ang constant. To the right side, we have cosine 15 R2 minus sine 15 degrees R3 is equal to 500. This is our equation number 2. Then, combine. Now, combine equations 1 and 2. So, ito ilista. We have negative sine 15 R2 plus cosine 15 R3 is equals to 2,000. Then we have cosine 15 R2 minus sine 15 R3 is equal to 500. So using two equations and two unknowns, we can solve for the values of R2 and R3. So, go to mode, equation 5, select ang 1 for two equations, two unknowns. So, input a negative sine 15. Muna siyang sa R2. Then, cosine 15 for R3. Then, ang constant is 2,000. Make sure ha nga, ang constant na siya sa right side. Then, in equation 2, we have cosine 15 for R2. Then, negative sine 15 for R3. Then, the constant is 500. Okay, equate ni mo ni siyang approximate value sa tong R2. That's 1155.39. So, 11, sorry, nagka-pilit. We have 1155.39. 39 pounds. Then, ang atong R3, bisag wag ipangita, ato lang yapon i-indicate, 2380.14. So, 2380.14 pounds. So, mo na itong gamiton sa next na to nga FBD. We will use this value. R2 is equals to 1155.39 pounds. Okay, let's proceed to the FBD. FBD of our wedge. Nga naa siya'y wedge angle nga 15 degrees. No? Mao na yung gitawag nga wedge angle. Ang mga external forces nga ni-act niya ni. So again, mo na siya to ang contact surface 2. This is our contact surface 1. So at the contact surface 1, natay R1 diri. Take note na ani agi diri ang normal force ha kani siya. Normal force. Then naa diri ang iyahang frictional force. Paana. So the reason why pa-upward siya it's because iyang gi-resist kay sa wall man ni siya nga part. Gi-resist sa wall ang downward impending motion sa ato ang wedge. Then kaning 15 degrees kani siya nga angle of inclination. This is due to the wedge angle, no? If imo i-resolve ang mga angles, this one is 15 degrees, no? Then natay angle P, our angle of friction, that is the angle between the normal axis or our normal force and the reaction force R1. And next, we have the applied force P na sa taas. And then we also have the reaction force R2. So applying Newton's third law, so kaganiha, ang direction ng R2 kay paubos, no? Ito ibalik sa previous slide. O, di ba? R2 paubos. Same ra gyapon ni og angle ha. Ang R2 na pod sa atong wedge, pasaka ra pod siya, no? Same magnitude but opposite in direction. So ang yang angle with respect to the horizontal is equal to the angle of friction, P. Okay. So maora man ning tulo ang mga external forces nga ni-act sa atong wedge. So therefore, ang ma-create ani kay force triangle. So as shown in this figure below, no? Natay force P paubos, natay R2 diri no? Then ang iyang angle with respect to the horizontal is shown right here, that's angle Phi. Then atong R1 pasaka. Now, kani siya nga angle, no? Ang angle sa R1 with respect to the horizontal is the sum of the wedge angle 15 degrees and the angle Phi. Ato po dahil Phi is equal to 15 degrees. Okay. Now, ato pangitaon ang kaning tulo ka mga angles, no? The alpha, gamma, and beta. So, solving for alpha, beta, and gamma. Ano lang, para di na to, kani ato lang po ning anaon pamaayo. Okay, alpha, beta, and gamma. Now, for gamma, kanatong gamma, actually, 90 degrees maning horizontal and kaning vector force P. So, gamma is a complementary angle of our Phi. So, butang gamma is equal to 90 minus P. So, that is 90 minus 15. So ang atong gamma is equal to 75 degrees. Then for our angle beta, no kanang beta, kung imo kita diri ang angle between the horizontal and the force P is 90 degrees. So beta is a complementary angle sa kaning sum sa 15 and the angle phi. So we can solve for beta by subtracting 15 plus phi from 90. So 90 minus 15 plus phi, that is 90 minus 15 minus 15. So that will give you 60 degrees. 60 degrees. Now, to solve for the last interior angle alpha, well, apply the theory for any triangle, no? That the sum of the interior angles equal to 180. So alpha is therefore equal to 180 minus gamma minus beta. So 180 minus 75 minus 60, that will give us, I must say, subtract the angle of 45 degrees. Okay. So nakompleto na mga angles diri so ang atong gipangita kay force P, no? So we can use either sine law or cosine law. So to solve for P, we will use, kaya ang pinaka-direct use sine law to solve for P. No, kay given man ta og value sa R2, nakuha naman ni nato from the previous slide. So R2 from the previous slide is 1155.39. So 1155.39 pounds. So ato relate ang side R2, no? Using sine law R2 over ang iyang included angle, that's beta. So sine beta is equal to the unknown force P. So P over ang included angle ni P, that's alpha. So sine alpha. So P therefore is equal to R2 times sine alpha over sine beta. Ato is substitute. So R2 is 1155.39. Then ang ato ang sine alpha, that is equal to sine 45 degrees over sine beta, which is equal to 60 degrees. Okay, so P is approximately equal to, so balik ka sa normal na pag-compute, 1155.39, then multiplied by sine 45 over sine 60. Okay, press equal. The answer is 943.37. So ang answer sa singer is 944. Do already kayo. No? Nagdaog gani sa ato ang pag approximate sa value sa R2. So P is 943.37. 943.37 pounds. So mao ni ang required force P so that mo move niya to about to move ni siya nga wedge. So para gid mo set in motion ni nga wedge, you have to increase the force. So higher than 943.37. Pero about to move pa lang yun, just to start. So the minimum requirement is 943.37 pounds based sa ato ang calculation. Okay. Naay pangutana ani?
Wala, sir.
How about the others? Naay pangutana? Okay, hearing none. So next meeting, we will continue our discussion sa other application sa ato ang friction. Those are the power screws, the belt and pulleys, and the rolling friction. So for wedges, dagani siya, no? naani siya sa Singer, dagay mga problems ni ani, and even sa matalino.com, no? So, visit the matalino.com na added to'y kung ano, kanang solution pod about wedges. So, kindly practice in solving problems related to wedges and katong sa frictions sa particle of sa rigid body. Okay. So kung wala na pangutana, no, tomorrow still 1:30 gihapon na, no? 1:30 gihapon tayo mag-start. Then we'll end up by madarag 2:30 pwede ra or 3. Okay?